The ideal scope is a diamond light performance assessment tool. Its reflective cone and magnifying lens create a structured light environment, which, when placed over a diamond, shows light return, light leakage, and contrast. Depending on how it was cut, light entering a diamond will either reflect and return up to the viewer's eyes or escape through the bottom as leakage or windowing, causing dark areas. When placed over a diamond, light passing through the ideal scope's cone turns red. Light that reflects inside the diamond and travels up is light return, which may be seen as brightness or fire. A viewer looking through the lens will see all light return as red. So in ideal scope light performance assessment, light return is red. Alternately, if light escapes through the bottom of the stone, that's leakage. It means the facets are acting as windows instead of mirrors. A viewer looking through the lens sees through the bottom of the diamond. Professional setups use a lighted panel under the diamond to expose obvious leakage. So in ideal scope light performance assessment, a viewer will see leakage as white or light pink. That brings us to contrast. Some light from above will always be blocked by the viewer, creating dark patterns. You can see the contrast effect in diamond photos because the camera blocks light the same way a viewer does. The on and off contrast effect when diamonds move is a dramatic component of scintillation. In ideal scope light performance assessment, the contrast pattern is black. Let's see ideal scope in action. Consider these stones. Under jewelry store spotlights, they both appear big and bright. We have an 80-pointer on the left and a 1-carat stone on the right. If both cost the same amount, you may be inclined to buy the 1-carat stone. Before you do, let's see them using ideal scope. Red is light return. The stone on the left shows red from edge to edge and across the center. The red is constant and unbroken by white leakage or windowing. The black contrast pattern is balanced and symmetrical. This is a well-cut stone that will show brightness and fire through many lighting conditions. Now, let's see the 1-carat stone. We can see it has fewer areas of red light return. There are rings of white leakage near the center and around the edges. The black contrast pattern is unbalanced and pooled at the center. This is not a well-cut stone. In a jewelry store under spotlights, they both seem big and bright. But now, let's see them in normal lighting. Here, the differences ideal scope reveals become apparent. The 1-carat stone loses brightness at the edges and now appears visually smaller than the 80-pointer, even though it's physically larger. In ideal scope analysis, diamonds which display abundant red light return across the center, combined with a balanced black contrast pattern with no white, light pink, or gray leakage at the center, will have exceptional light performance throughout many lighting conditions. Alternately, diamonds which show fewer areas of red light return, replaced by a ring of white, pink, or gray leakage at the center, or black pooled contrast at the center, will have reduced light performance in many lighting conditions. With ideal scope analysis, you can easily tell which diamonds will remain bright and dynamic, as opposed to diamonds which will have reduced performance in certain lighting.